Hi everybody, this is Mr. Brooks, and today I'm going to talk about expected value. Excuse me. And expected value is a concept used a lot in insurance, and the definition is it's an anticipated value for an investment at some point in the future. The way I like to think about it better is like, how much would you expect to get out of something that happens? Like, or how much would you expect to get out, from an outcome? So the way you calculate it is actually pretty easy. It's just take the probability of the outcome times by the value of the outcome plus the probability of the next outcome times the value of the outcome. And this could go on. Like if you had three outcomes, you'd have plus probability times value, and if you had four, you go on. And so you could have two outcomes, maybe like this is probability of a win and how much you win by winning, and probability of a loss times how much you lose by losing. So, for example, but you could have five, six, or seven or more. And then this is a nice little model of what's going on. So you'll see half the outcomes have a value of one, a quarter of the outcomes have a value of two, the little fuchsia violet color, and right here in teal, a quarter of the outcomes have a value of three. So it's one half times one plus one quarter times two plus one quarter times three. So some of the formulas can look a little daunting, but you're really just multiplying and adding. So when we talk about expected values, we need to talk about fair games. What is a fair game? A fair game is a game that neither side has an advantage, and you would expect neither side to win, quote unquote. Think about if you go into a casino and you're thinking about what games to play. The house has the advantage in almost all the games, not all the games, but um, like for example, for slots, you know, or you should know, that the house has the advantage and that the slots will take more money than they pay out. So you might win early and then you leave, you cash out. But if you play and you play and you play and you play enough and you keep playing, then you're gonna see that the casino has taken more of your money than it pays out. Another example might be like, how much would you pay to play a game? And maybe you're playing with me, and I say, hey, we're gonna flip this coin, and if the coin lands on heads, then I'm gonna give you $1. And so, how much would be a fair amount to pay for that? Well, since half the time it lands on heads and half the time it loses, then the fair play would be 50 cents. So if you paid 50 cents per turn, if we played and we played and we played, theoretically, neither of us would have an advantage. Now, again, theoretical is not practical. It is possible that you could win several dollars, or it's possible that I can win several dollars. And but theoretically, they should balance out. Okay. So let's do a little exercise right here. So let's say you have a basketball player, and the basketball player we know his shooting percentage because we keep stats. And let's say that every time this basketball player shoots a 2-point shot, he makes 50% of his 2-point shots. Okay. Um, and then every time he shoots a 3-point shot, he only makes 20% of his 3-point shots. So the coach has the decision to make. How am I going to best use this kid? Am I going to tell him to shoot 3-point shots or 2-point shots? How much money, how many points can I expect to get out of it? So what is the expected value of each 2-point shot? Well, the he makes 50%. Um, that's the probability, and I'm going to change it to decimal 0.5, right? So that's 50%, and then the expected value of each of those is 2. So that would be 1. Half of 2 is 1. So each time he shoots a 2-point shot, we would expect to get 1 point. Now, he never gets 1 point because either he misses and he gets 0 points, or he makes it and he gets 2 points. But the expected value is 1. So for over here, for 3-point shots, we know he makes 20% of his 3-point shots. The 3-point shots are, of course, as it says, worth 3. And that is worth 6/10 of a point, six tenths, 0.6 points. Okay. So Which shot should his coach encourage him to take more of? He should definitely say, go out there and shoot 2-point shots. You're going to score the most 2-point shot for our team if you shoot 2-point shots. And forget about the 3-point shots. Yeah, you're going to score more points if you make it, but you're not making enough of it to make it where it's worth our time. Okay. All right. There's a cost of play. Okay, so you go into a casino and you pay $1 into the slot and you win $5. You did win $5. You can tell everybody you win $5, but that's not entirely the full picture. You won $4 because you gave $1 and you got $5. So really, you won $4. So as a rule, you need to subtract the cost of play away from the winnings if you're talking about paying into the game. Okay. So let's take a look at this one. Suppose you're offered a chance to play a game where you pull a card out of a deck at random, shuffle deck, so no tricks. You draw one of 12 face cards. If you draw one of 12 face cards, then you win $13. But you have to pay $3 to play. Would you play this game? So first off, let's get some background information. There's 52 cards in a deck. That's important to know. And then there are two outcomes. Either one of two outcomes is going to happen. Either you get a face card, and in this case, we're going to say that jacks, queens, and kings are face cards. We're not counting aces. Some problems will tell you aces are a face, and some won't. But there's 12 face cards, and you win. And there is 40, because 52 minus 12 is 40 cards with a number on them, or I guess ace is 1 in this case. So we're going to have 12 out of 52 is the probability of winning. Oh, my mouse getting stuck. And then we're going to multiply that by the winnings. But don't do 13, do 10. It's 13 minus 3 is the pay. And then we're going to add that to the other outcome, and that's, you have a 40 and 52 chance. It's a terrible 5. And how much do you win here? Well, you win negative $3, right? Okay, and that's it. That's it. So we're going to take our calculator, and we're going to do 12 divided by 52. And of course, you can change that to a decimal, or you can reduce the fraction, multiply it by $10, and you get 2.3. So this is 2.31. And that's rounded, of course. But and then the other one is 40 divided by 52 multiplied by negative 3, and that's negative 2.31. Okay, so in this case, it's a fair game. Okay. If you played it enough, you wouldn't win anything. But in this case, it's a fair game. It is. So awesome. Okay, and what would a fair game to play to be? It would be $3. So I guess like a takeaway for this is, if the person were to charge you $4 to play, then you would lose, or you would expect to lose. Now there's a chance you could win, sure, but the expected value is you would lose. And if you could play the game for $2, then you should play the game, because you would expect to win, and you would expect to win how much? $1 each time. So, all right, let's see. Okay, so one more problem here, and this one says you're going to buy a car from a person. Maybe you met this person off of Marketplace or Craigslist or something. You see this car, and you're like, oh my gosh, this could be a good deal for me. But the person's going to sell you the car for $3,000, but imperfect market, you think, hey, there's a chance that this car is actually worth more than $3,000. There's a chance I'm going to get a really good deal on this and make some money. So you think that there's a 60% chance based on all your reading and your research and how you talk to the guy and the questions. You say there's a 60% chance that this car is actually worth $5,000. I'm going to make some money off this. But there is a chance that the car is actually not worth anything. It's a lemon, or maybe, turns out that the engine block is seized up or something, or it's going to need a transmission right away. So there's a 10% chance that it's actually only worth $700, maybe scrap metal. I don't know. What is the expected value of buying the car? So you're going to buy the car and you want to know, like, are you coming out ahead? Okay. So it's three possible outcomes. And the first outcome is there's a 60% chance that the car is worth $5,000. Okay. And then there is a 10% chance that the car is worth $700. And then the other chance is that it's just, it's worth $3,000. The selling price, the asking price is correct. Okay, which of course there's a chance of that. So how much is it that there's correct? Well, there's 100% chance. It has to add to 100%. So I've got 0.6 and 0.1. So that leaves me with a 30% chance, right? 30 plus 10 plus 6 is 100. That it's priced correctly and you've got yourself a $3,000 car. Okay. Okay, so what is the expected value of the car? Okay, so this would be 0.6 times 5,000 plus, this is 0.6. Plus 0.1 times 700, and you can't see me, but I'm putting this in my calculator, plus 0.3 times 3,000. And I'm putting in the calculator just like this, and this is going to be equal to $3,970. So the expected value of the car that you're going to buy is $3,970. And so maybe another way to think about this is how much are you expected to gain? So like we'll call it profit, right? Which, is kind of gain. So the profit would be take away $3,000 and it would be 970. So you would expect to make, that's a bad 9. You'd expect to make $970 off of buying the car. Now, that's a theoretical expected value and a theoretical profit. But that is the expected value. So that could be a risk you're willing to take, right? Okay, so good luck on the assignment and hope that this was really helpful.